Here we're showing a very interesting feature of the particle insight. The particle insight has the ability of actually detecting the velocity of particles as they pass through. So the velocity is something that's measured by a particle tracking feature, and basically what we're going to do is we're going to try that right now. Now what we have in this system is basically we do have some debris in the system, but we have predominantly some polystyrene latex that is located in there. It's about 20 microns more or less. Some are out of focus, but we're rejecting those. We set that up already for it to reject particles that are out of focus. So basically what we're going to look at is under run conditions. We are going to run about 5,000 particles, but then under special features we're going to turn on particle tracking. And under particle tracking we're going to say that the particles are going to go from top to bottom. And actually if you go to help under here you'll get all the information on particle tracking if you want to read that under run conditions, and hit OK. At this point when I hit clear start, it's going to ask me what select measures for particle tracking. I could select up to 4 measures. So not only can I detect the velocity of the particles going down, but I can actually give you the diameter of those particles that I'm tracking. Let's say in this case the circularity, smoothness, let's pick one more, aspect ratio, and hit OK. And then I can hit start. When I hit start, basically I could do a run. I'm doing basically a run here, an analysis run, and I'm running several I don't know what the frame rate is, and what right now it's basically trying to run several running several 15-20 frames per second, but looking at that data. So we're doing a regular analysis, and as we can see here, there are some big particles in there, but we also have the polystyrene latex, which you're looking at here. And as this progresses, we will go ahead and get to a point that it'll stop, and we'll see the particle tracking. Now if we'd like, we can stop it at any point in time. Let's say we wanted to stop it now and stop it early before we get to the 5,000 particles. And I think at this point I'll just let it run to the end, since there's not much left, and I don't want to make this video too long, and we'll see what we end up with. So once again, basically we're looking at a particle shape here of has a mode about 20 microns. Those are the particle styrene latexes. There's some big particles that went by. By number those wouldn't show up, but by volume they would. So now that we're getting close to the end, we'll let it run. And over here we're measuring 5,000. So at this point, now we're pretty much done at this point. It finished, and if we go in, we can actually go in and look at the Excel file that it created. So let's go ahead and look for that Excel file that it created here and do an open. And it should be located under C. Let's see, under program data, particle insight, export, and cellular velocity 1.pt. So let's open that up. And basically what we see here is we see the velocity of each particle. We can see the frame it was found in at first, the offset, how far away from the center, its approximate size, how many frames it was found in, and the ECA diameter, circularity, smoothness, and the aspect ratio. In some cases it can't do a measure because it wasn't enough information. Possibly in this case it was a very small particle, so there was not enough information for it to capture smoothness at a 1.5 micron particle. Now it's very interesting with this, and what I'll do at this point, I'm going to do an increment, and now it's called settling velocity 2. What I find very interesting is if you have a very homogeneous run, you have these particles being suspended, you can actually do this run, but do it based with its natural settling velocity. So if I turn the pump off, now really the only thing that's affecting this is the movement of the liquid and particles flowing down. Now obviously in this case there may not be optimal because we have some very large bubbles that might be going up, some particles that are flowing their way down and disrupting things. But basically if we get to a point that we have a good number of particles, we can actually go in and look at the particle velocity. In this case, once again, not very appropriate. These polystyrene latexes tend to flow up because they're somewhat buoyant. But if we had some particles that were very heavy, we would actually see how those particles would flow down. Let's say possibly with that one, if we were in better focus, we could probably capture the information just on that one. And say clear start, and see how some of these particles are actually settling, and now they're making their way down. So obviously before there was probably some bubbles pushing them up, but they're slowly settling down. Once again, if you had some very dense particles, it would be much more appropriate. We're not going to wait for 5,000 particles, but here what we can do is stop. We can save it, and then we can go into the and open up the new one, which would be open the second velocity run. Here we'll see that the velocity obviously much slower, so it's much slower velocity, but we can see the same particles. We saw them obviously in much more frames. This one was seen in 68 frames, 77 frames, and it gives you the particle shape of each one. So this is very useful information. You can actually see possibly in an array of particles, let's say if the particles that have that are smoother and or let's say an aspect ratio of 1, maybe not necessarily, but let's say the particles had a higher aspect ratio, maybe were more flake-like, if they flowed down slower. And if they flowed down slower, they'd have a slower velocity, and they could actually have a higher aspect ratio. So those are some of the things you can play around with, and that are very interesting with particle velocity. Anyway, I hope this helped. Thank you.